So we've just learned how to solve systems of equations, which involves more than one variable with more than one equation. And we've only been focusing on the elimination method. Let's see if we can work in some different methods in these examples. So 58 gives you information about the charge at a movie theater. You are charged $9 for an adult ticket and $7 for senior citizens. We're not worrying about the children's price right now. On a day when 325 people paid an admission, the total receipts were $2,495. How many who paid were adults and how many were senior citizens? And the first thing I encourage you to do is define your variables. You can call them X and Y if you want to, or you can be a little bit more interesting with them. I usually stick with X and Y. How do you define your variables? So I like to jump to the end of the example and look at what you're trying to calculate. How many were adults? And how many were senior citizens? And so that is going to help us figure out how to identify our variables, because we need an answer for this is the number of adult tickets and this is the number of senior citizen tickets. That helps you understand that one of your variables is the number of adult tickets and the other variable is the number of senior citizen tickets. And be as specific as possible with the descriptions of your variables. Don't just say X is adult and Y is senior citizens. Be a little bit more specific with the number of tickets for each of those individuals. So the first thing you're told is the price, right? $9 for adults and $7 for senior citizens. And you're also told the total price that was paid that day, the total receipts were $2,495. So if X is the number of adult tickets, and each adult is paying $9 for a ticket, 9 times X is the total amount of money that was paid by the adults. Next, senior citizen tickets were sold for $7 a piece. Each of the Y senior citizens paid $7 for a ticket. So 7 times Y tells you how much money the senior citizens altogether paid for their tickets. And then the total money brought in from these two groups of people were $2,495. The next equation is going to deal with how many tickets were sold. Okay, how many tickets were sold? And that is told to you right there. 325 people paid admission. And there's only two types of people that we're referring to in this example. We've got the adults and we've got the senior citizens. So the number of adults who bought a ticket plus the number of senior citizens who bought a ticket adds up to 325 total people that day. This is your system of equations. We attach them with this little bracket on the side to represent our system. We want to solve for X and Y. So you could play with the numbers. You could try to play with X and Y and see what numbers make both equations true, but that could be pretty time consuming. We're going to solve this using algebra methods. We've already seen some examples on how to solve it with the elimination method. So we're going to solve this one now using substitution. The first thing you want to do is rewrite one of your equations with one of the variables by itself, right? And so I'm going to work with the second equation because each of my coefficients on X and Y are just 1. This is much easier to do than the first equation that involved coefficients of 9 and 7. So take the second equation and select one of those variables, doesn't matter which one, and get it by itself. So if I want to solve this equation for X, you would have to subtract the Y from both sides. And that would give you X is equal to 325 minus Y. And now's when the substitution comes into play. The 325 minus Y is going to be substituted into the other equation in place of the variable X, right? Because they're both equal to X. So that's where I want to put that expression into. And that is going to say 9 times the entire 325 minus Y plus 7Y equals 2495. It's really important that we use parentheses around this quantity that we substituted in because the entire quantity is now going to be multiplied by 9. So when you distribute the 9, you end up getting 2,925 minus 9 times Y plus 7Y equals 24.95. Now we're solving this equation for y. So we've got negative 2y here. We subtract the 29.25 from the other side to get that y by itself. You get negative 430. Divide both sides by 2. You end up getting 215. So remember what y stands for. Y is the number of senior citizen tickets. So I'm going to write that here beneath my solution. And that's one of my answers. I also have to figure out how many tickets were sold to adults. Now you substitute the value 215 back into any of your equations that you have above that involve x's and y's, and you're going to figure out the solution for x. I like this one. I like that one quite a bit because it's already solved for x. I just have to plug in the value of y. So if I plug in the value of y into that equation, I end up getting x equals 325 minus 215, and this is equivalent to 110. 110 adult tickets were sold that day. So those are your two solutions. You've got an answer for both of the questions in the problem. How many who paid were adults? 110. How many who paid were senior citizens? That's 215. And both of these answers for x and y make both of the equations in your system true.